Hi, Doc Revis here with a short lecture on oxidation and reduction. How to solve oxidation reduction problems. That's the goal. Let's take a look at some examples here. In this case, we have a single displacement reaction that's already been balanced. Magnesium plus HCl to give magnesium chloride and hydrogen gas. Step one is to assign the charges. When you assign the charges, you do it by conventional means. Note that all compounds start with a positive charge on the left side and a negative charge on the right. However, in the case of an elemental species, as in magnesium is in its elemental state and hydrogen in its elemental state, you will assign a 0 to that. Once you assign the charges, then ID whether there is oxidation or reduction in that particular species or that particular element. In the case of magnesium, it went from a 0 to a +2. Again, the charge has been assigned by conventional means. In the case of hydrogen, it went from a +1 to a 0. Chlorine did not change, therefore we don't have to consider it. So since oxygen went from a 0 to a +2, that's oxidation. The number became more positive. That means it's oxidation. In other words, oxidation loses electrons, and since electrons are negative, it will become more positive. Reduction occurred in the case of hydrogen. It went from a +1 to a 0. Reduction gains electrons and becomes more negative. So again, magnesium has been oxidized and hydrogen has been reduced. Next, we just want to take a tally on the number of electrons involved in this process. So count how many electrons involved. Sometimes you'll have problems that will ask you that, and other times it won't. If it's not asking you for this, then just answer which ones oxidized and which ones reduced. In this case, I just want to take a tally on these. So here we go. We note that in the case of the oxidation of magnesium, we had 2 electrons and going from 0 to +2 with 1 magnesium, therefore a total of 2 electrons. In the case of hydrogen, we had a +1 to a 0, which is 1 electron. However, we have 2 hydrogens and therefore we have 2 electrons. So electrons balance out. Next, we'll decide what's the oxidizing and the reducing agent. One simple way to know this is that the oxidizing agent is reduced and the reducing agent is oxidized. So in this case, we know that magnesium was oxidized, therefore it is the reducing agent. It caused hydrogen to be reduced. HCl, or at least the hydrogen within the HCl, is an oxidizing agent. It caused magnesium to be oxidized. Therefore, it is the oxidizing agent. So to repeat, magnesium is the reducing agent and hydrochloric acid, HCl, is the oxidizing agent. Magnesium was oxidized from 0 to +2. Hydrogen was reduced from +1 to 0. The total electron balance was 2 electrons oxidation, 2 electrons reduction. Let's do another problem. Synthesis or combination reaction. We have the balance equation here of aluminum plus bromine gas gives aluminum bromide. We do the assignment of the charges first. 0 and 0. 0 on aluminum because it's in the elemental state. 0 in bromine because it's in its elemental state. If we do the charge assignments to aluminum bromide by whatever conventional means you're used to, then aluminum's +3 and bromine's -1. Therefore, if we ID what's oxidized and what's reduced, we note that aluminum went from 0 to +3. It is therefore oxidized. It is more positive, therefore it's oxidized because it lost electrons. Bromine went from 0 state, its elemental state of 0, to bromine -1. Therefore, it was reduction. Reduction occurs when the electronic count, or at least the charge that is, becomes more negative. So when the charge is more negative, we know that that is reduction. Then we count how many total electrons involved. If this is a problem, you have to work to tell how many electrons involved. Then you'll simply take a look at the number transferred. We have 0 from aluminum. It lost 3. And it was 2 aluminum, so that's a total of 6 electrons involved there. Bromine gain 1, but there are 6 total bromines. 3 times 2 is 6 total bromines. Therefore, we have a 6 electron transfer there, or involvement there as well. So we know that's balanced. So what is the oxidizing and reducing agent? We know the reducing agent is aluminum because it caused bromine to become reduced. We know that bromine is an oxidizing agent because it caused aluminum to become oxidized. Aluminum was oxidized, therefore it is the reducing agent. Bromine was reduced, therefore it is the oxidizing agent. Let's do another problem. This is a decomposition reaction. It's already been balanced. Balancing equation is important, particularly if you want to know the total electrons involved. So here we have the species KCl3, and we go to get KCl plus 3 oxygen gas molecules there. So we assign the charges again by whatever conventional means you use. We note that potassium has a +1, chlorine has a +3, and oxygen has a -2. And potassium on the right side, on the product side, +1, chlorine with a -1. Oxygen is in an elemental state, therefore it's assigned a 0. So an oxidation occurred then from oxygen on the left side in the reactant to oxygen on the product side. It went from a -2 to a 0. It became more positive, therefore it is oxidized. Chlorine on the left side in the reactant had a +5, and it went to a -1, therefore it was reduced. It underwent reduction because it became more negative. It gained electrons. Oxygen on the reactant side lost electrons. If we check the electron balance just simply by counting and simple math, we had 2 electrons involved in oxygen, but we had 6 oxygen molecules. That's a total of 12. In case of chlorine, we had 6 electrons times 2 chlorine molecules, gives us a balance of 12 electrons each. The number of electrons oxidized must equal the number of electrons reduced. If we identify the oxidizing agent, in this case KClO3 is the reducing agent, we note here that oxygen in the KClO3 was oxidized, therefore it is the reducing agent. Also, KClO3 is the oxidizing agent because we note that chlorine here underwent reduction, therefore it is the reducing agent. Excuse me, it is the oxidizing agent. Let me repeat for clarity. KClO3 is both the reducing agent and the oxidizing agent. KClO3 caused both events to occur. All right, there you have it.